The aims and objectives of this video is to identify the structure and components of a telecommunications network cable. I will be talking about different types of connectors used in a network. These connectors will vary depending upon what type of network they are connected to. This can depend on if the cables are twisted pair, coax, telephone or fiber optics. The first connector we will talk about is the RJ45. It is one of the most common connectors on the network. This is an 8-pin connector. This is used to connect computers and networks on a local area network. The RJ45 is used with unshielded twisted pair. The untwisted pair has 8 wires within it that are set in a certain order that slot onto the RJ45 connector and then are crimped. One of these RJ45s will be at each end. One will connect from a computer to a switch, a router, a modem, and they will be able to connect to the internet. They also has on the RJ45 a locking nut that holds it in position and secure. A UTP coupler is used to extend a RJ45 cable. The cables will have a RJ45 at each end, and basically this will allow you to extend it so there's no need to run a longer cable. This will allow you to extend one RJ45 cable with another. Another connector that is similar to the RJ45 is the RJ48. This is used on shielded twisted pair. It looks similar to an RJ45. Shielded twisted pair has a shield around the paired cable to ensure that it does not have interference. The RJ48 is primarily used on T1 lines. The RJ11 connector has 4 wires and is mainly used to connect telephone equipment. This is mainly used to connect the network through the computer's modem. It locks itself into position using a locating catch underneath. The BNC connector is mainly used with RF and used to connect coaxial cable. The BNC is also used mainly on analog and digital video transmission, also audio. This is now becoming a legacy piece of equipment. Here is a BNC-T connector. This allows you to connect 3 coaxial cables together. A BNC coupler that joins 2 cables together, and then finally you have a BNC terminator. This is placed on the end of the coaxial cable. The next connector is the F-type. These are threaded and mainly used on coaxial cables. These are used by cable providers and satellite so that you can connect them to the equipment. For example, a cable modem or a set-top box. For example, if you have Virgin Media, you will find these are on the end of the cable that connects to your modem and your set-top box. Also, if you have Sky, these will connect one end to the dish and one end to your set-top box. These are also used on broadband satellite. Next connector is the USB. USB, you will find that on many desktop, laptops and equipment. As you can see, the U on USB stands for Universal Connector. This means it can be used for many different applications. A common use for the USB is to be placed on a wireless adapter. This allows you to connect to the network without having any cables. Or you can use an adapter so that you can connect directly to the Ethernet using the USB Ethernet adapter. This will allow you to connect to an Ethernet based network. Now we're moving on to fiber optic connectors. Fiber optics allows a pulse of light to go down the network, and I will now cover a selection of connectors. The main difference between these fiber connectors are the size and the method they use for coupling. The first connector I will cover will be the SC connector, the standard or subscriber connector, sometimes called the square connector. This connector was one of the first on. This uses a push-pull connector similar to audio and video plugs. These are commonly used between floors within a building. The next connector is the MTRJ connector, standing for Mechanical Transmission Registered Jack. This connector uses a latched pull connector. This was also designed to replace the SC connector, using two fibers in one design. This connector is becoming quite popular within fiber networks to date. The next connector is the LC connector, sometimes called the local connector or Lucent connector. This connector was designed by Lucent. This is commonly used between floors. This was designed to compete with the SC connector. This connector is about half the size of an SC connector, making it more useful for highly populated racks. It has a lock-in latch very similar to the RJ45. The last connector we will look at now is the ST, standing for straight tipped, commonly used with single mode fiber. Also, it has a locking device which makes it a secure connection. This is a large size connector which was developed by AT&T. Because of the large size, the use of this connector is now slowly decreasing and smaller connectors are now available on the market. Fiber couplers are very similar to the UTP ones. These are used to connect two of the same connectors together. These are not to be confused with fiber adapters. Fiber adapters connect two different types of connectors together. Here we have an example of two ST connectors using a fiber coupler to join them together. Now we're going to talk about UPC and APC connectors. This is end-facing connectors. For an example, we will be using ST connectors using a APT and a UTP end. When two fibers join together, the ends aren't always perfect. At the point of where the two fibers connect, a light is transmitted from one to the other. Sometimes there can be some imperfect ends. If the ends are imperfect, some of the light can be reflected back towards the light source. There can be some signal loss. This is common in UPC connectors. This reflected light back to the main source, and as technology increased, a better end was designed. So to overcome this problem, the APC connector was made. This is an angled tip that allows the signal not to be reflected back to the original light source. So having the angle allows the signal that is reflected back to reflect into the wall and not affecting the signal loss. Thank you for watching this. You will now have a couple of tasks to carry out.